Hi, welcome. This is week 3 and I wanted to give you a sense today of what we did last week, like I did last time. That's the first part of the agenda. But the second part of the agenda is to move on to using the stuff we used yesterday to something that's extremely important, which is how do you make decisions using the tools we have acquired. Obviously, even yesterday or last time, we did use tools to make decisions, but this has a slightly different twist and an important one. And it'll give you a flavor of how the real world works. Again, everything will be done first with an example. And as promised, my job here is to make you love finance. And because it is awesome, not because I'm artificially trying to do so. And the only way to do that is to show the applicability of something before you start throwing math or formulas at it. So I hope you like that style. So let's get started. So today is week 3. As always, the first thing that I do, the first thing that I do, as always, is to recap the previous week. And last time what we did was, and I want to just give you a flavor with a little bit of writing on the side, is last time we defined and worked with things like PV, FV. This is present value, future value. And if you want to draw a timeline, what we did was we recognized this was somewhere here and this was somewhere here. The length of this interval or number of periods clearly depends on the nature of the problem. So I'm just picking 10 just for the heck of it. We recognize how to move forward and back using just PV, FV. And in the beginning, we just concentrated on one cash flow. That was week 1. Week 2, we introduced something called PMT, which can occur every period. The little bit of artificiality about PMT is that it's fixed for every period. But as we saw yesterday, in most situations, or in many situations, we ourselves choose to keep that number the same. For example, loans are taken on fixed rate interest. We deposit money into banks or into a portfolio based on our needs for the future and so on, but at a reasonably constant level. But the important point is not that this number is exactly fixed, is that this being fixed allows us a lot of flexibility to do problems, and we can later, like today, change PMT and make it different every year. But the process, the way of thinking is exactly the same. So what I'm going to do now is I'm going to do a recap of last week using something that we did last time. So I'll give you a minute to read this problem again, and you'll recognize this problem. And the reason I'm doing it is because it kind of captured everything we did last time. But as you read it, you should see a difference. So I'm throwing in something new into the problem so that you can think creatively to do this problem again. So the problem again states that you're 30 years old. You believe you will save for the next 20 years till you're 50. This is exactly the same as last time. For 10 years following that, until you retire at age 60, you have an inability because of your expenses, college expenses, weddings, and so on, to save. And remember, you're at 30, you're trying to figure your life out in the future. And this is not difficult to do. This is all for your own thinking, not somebody else telling you what to do. So I'm kind of empowering you to think for yourself. Now, at 60, if you want to guarantee yourself $8,000 per month after that, till you, quote unquote, are no more at 80, how much do you need to save for the next 20 years, starting at age 30? But the one wrinkle I've thrown in is I've made this from an annual to a monthly problem. And I'm going to let that stay up there for a second. Since we've seen this problem before, I'm creating a new twist, and we shouldn't be able to, worry too much about the fact that there's months now. On the other hand, I think the problem becomes much richer and much more real world, right? Because of compounding. And you should always pause before you say that. Okay, so let's get started. And I'm going to, since we are beginning this class, I'm going to just try to address this issue right away. So first thing you always do is draw a timeline. And I'm borrowing this timeline from last time. But notice I've done something. And if you're looking at this slide carefully, what you'll notice is that I have made my life very simple by doing the first thing, which is under my control, is defining a period according to the nature of the beast. So the problem here says that I'll be saving monthly, and the timeline converted to months solves a lot of my problems. So the question now is, between years 30 and 50, there were 20 years, right? But actually there are 240 months. Again, between years 60 and 80, there were 20 years, there are 240 months. So the question is, between 50 and 60, when I'm not able to save, but I'm not dissaving, right? How many years are there? 10. But recognize that no longer can you work with years. And therefore you have to convert that to 120 months. So that's basically the nature of the beast. So let's get started and do this problem a little bit faster than last time. So what I'm going to do is I'm going to show you months coming here. And why am I starting at this end? Why am I time traveling? Because remember, finance forces you to look forward, and that's one of the best things about it. And as I told you last time, don't look back. Look forward, because you're making decisions. And then decide, when you look forward, what is it that you're trying to solve? So here, you want how much per month? I believe my numbers now are 8,000 per month you need for a long period of time, right? So the PMT you'll put in solving this problem is 8,000. And we'll do it in a second. N is how much? N now is not 20 years, it's 240 months. Basically, this has to match this. If these two are not aligned, you have a problem. Most importantly, you have to align this with the problem. So if an annual interest rate is stated at 8%, the monthly interest rate should be 0.08 divided by 12. If you were getting compounding on a quarterly basis, it would be different. Daily basis, it would be different. So the question here is now, how do I solve this problem, and what will it tell me? Because we've done this problem before, I'm going to recognize, you remember, that the first thing I'll try to do is PV of what I need, and I'm going to put a subscript here 60, so that it's, you see, the calculator Excel doesn't know where you are, but you do, right? So you know when you solve this problem, you're not at 0.30, you're at 0.60 in the future. You're already there in your mind, and you're looking forward, you're not looking back. Even though you are at 60 and it's yet to come, 30 years from now, when you're solving this piece, you're looking forward, the same principle. So let's see. This is a tough one to do, right, in your head. As I said, if you do it, there's something wrong with you. So let's presume you can't do it, and let's use Excel to do it, okay? So what I'm going to do is I'm going to toggle and go to Excel, okay? So let's see. And I had promised myself in this class that I wouldn't do a lot of execution, but I'm not doing execution without hopefully a need for doing it. So hopefully this is helpful to you without being hand-holding. So remember, what are we trying to solve for? We're trying to solve for a PV problem. Even last time, remember, if I screwed up, is I thought I was solving a PMT problem, but I was actually solving a PV. So the thing that you're solving for is the function, and it's PV. Remember in your head, it's PV in year 6. Now, what is the interest rate? 0.08. But you got to pause. You do not have annual compounding. You have monthly compounding. So you divide that by 12. How many periods do you have? 240. Don't put 20. Because if you put an interest rate of 0.08 divided by 12 and you put 20, your annual interest rate is almost non-existent, which, by the way, matches with reality these days. But for the time being, let's do this problem. Okay? So you have 240 PMT, and then FV is what? We don't have a future value here. And you have we got all our numbers in there? 240, yes. And the PMT is something I do know. So the PMT comes before FV, and I press 8,000, right? So what do you get? You get $956,434. And I'm going to avoid the cents, right? So everybody recognize this? So it's pretty straightforward, and I'm going to leave it there, and I'm going to toggle back to our presentation. So now we know, by the way, this is art form. I'm going between different media without you even knowing. I hope you like that. Anyway, so PV60 we saw was, and I'm going to confirm this with my own notes, 956,434. I'm writing all these details simply because as I said, my philosophy is that I will not give you resources unless they're absolutely necessary for you to then sit back and consume. I want you to work through these problems yourself, so I'm giving you some minimal information. Now the problem is I cannot stay here. I got to match the tools I have to the problem I can do. Now clearly when you become proficient, you can do this in an Excel and do it all faster and so on, but let's do it a little bit logically. I want to bring it back here. Why do I want to do that? And the reason is I do know how to calculate a PMT, which I'm trying to calculate. What is my saving monthly? If I know its future value at this point, but if there's a gap, it's a problem, right? So why not take the problem to something you know how to do rather than just wait there and expect some magic to occur? And it's not a big deal. It helps your thinking. So now what do? Let's go back and try to understand what's going on and do Excel again. And so what I'm going to do now is I'm going to, as I said before, toggle back to Excel. Now the good news is I already have a number up there, 956, right? So let me take equals PV. Why did I do PV? Because now I'm bringing something at year 60 to year 50 to match what I want. So let's do it. You have to be a little careful because I think, as I said, if you're not careful, you'll put in the wrong numbers. So now 0.08 divided by 12. Again, please remember not 8%, but 12th of that. How many periods? Well, between 50 and 60. There are 10 years, but 120 months. Right? So we got those two numbers, and now we need to figure out what do I put in next. And remember, the next item here is PMT. That's how it's been set up in Excel. But I don't have a PMT, right? This time I don't. I put a 0 there, but I do have a future value. And the future value is sitting in which cell? We just solved the problem. I've retained that cell, A1. Look what happens. I think this happened last time too. Just because you're doing it monthly doesn't mean this won't happen. The value has dropped drastically, in fact, to less than half. And what's the reason for it? 120 months have passed, and the monthly interest rate is non-trivial, right? So now we are at a point where this, again, let me just toggle back to the PowerPoint. Now the good news is, where am I? I am now at this point. and I have a number that I can deal with. I think it's 430,896. 430,896. So what does this number mean? Let's just pause for a second. It was more than twice here, right? So what does this number mean in English? This is the amount of money I should have in my bank at age 50 to support what? To support all my post-retirement 8,000 a month expenses. So that's one way of thinking about it. So now, however, I don't have that money, right? So I need to act today, starting end of next month, to start saving. But what kind of a problem is it? It's a PMT problem. How much money do I save a month? Whose future value? I already know. Make sense? Okay, let's do it. Just one more step, and then after that I will take a break, because I want you to kind of think about this a little bit and see what's going on. So let's go to Excel. So now if you look at the two numbers on top, the first number is, it's showing negative simply because I'm putting a positive number as a payment. So now 430 needs to be in the bank at which time? At time age 50. That is 956 it grows into if it stays in the bank or in a portfolio. So let's do the PMT problem, because now we are solving for PMT. How many periods do you need? First is you need 20 periods, but you also need a rate of return before that, 0.08 divided by 12, right? Everybody got that? Okay. How many periods do I save for? 20 years, which is 240 months. Fair enough? Got it. Now, the next number, and again, you have to just be paying attention because you're as to what Excel offers and in which sequence. And don't try to memorize it because you've got junk in your head, doesn't help. The next item is PV. We know we don't know the PV. We could do the PV, but we don't know it. What is the future value and where is it sitting? It's not sitting in cell A1, it's sitting in cell A2. Remember, what's sitting in cell A1 is the future value at year 60, and you want it at year 50. Okay? So let me see what I did. You see, I can guess when I'm doing something not quite right. So you have A2, 240. You see, I told you should put 0 there, and somehow I put a 0 and it disappeared. But you know, I have intuition. And once you start doing this number, a number will jump out at you and say, that doesn't make sense. So saving $3,000 a month just doesn't make sense, right? Today to get $8,000 in the future. Look how much are you saving. You're saving about $732. So just to recap everything, let me go back one more time and show you what you've done. Basically what you've done is, sorry, just one second. Basically what we have done is we have solved a problem where we started off wanting 8,000 a month, 240 times. We figured out its present value at this stage. We figured out its present value at this stage. And then we said, how much do you need to save every month to solve this problem? Look, I'm not going to enter the items here. We already did this. What I'm going to enter is, what did we get over here? We got 732. And I wanted you to think a little bit about it. Look at the power of time and compounding. I have to save only $700 a month plus 730, right? But in return for that, I'm able to enjoy $8,000 a month. The thing that has changed is time between the two. Why is it that I can save so little and enjoy so much in the future? One, because time has passed. Two, because of the interest rate. I repeat again, an interest rate of 8% a year, which is 8% divided by 12 a month, is a very high number. First point. Second point, yes, you are working hard, hopefully, to get this saving possible of 700 plus. But remember, who's giving you the benefit? The world is investing your money in good ideas, hopefully, and we'll see what good ideas are later today. That's the topic of today's class. You are able to enjoy what the world has to offer through the ability to invest in other things. So that other thing we called was a portfolio. But remember, that portfolio grows over time simply because of two things. More months, more the growth. Higher the interest rate, higher the growth. The two together is the effect, profound effect of compounding, which even Einstein said he couldn't fathom. And turns out that's why you need Excel and other things to calculate these numbers. So I hope this put everything together one more time, and the small twist of going from a year to a month helped. Do one last thing. Answer the following question. If compounding is monthly and the stated interest rate is 8% annually, what really is the annual interest rate? I can give you the directional answer. It has to be more because of pause compounding. And I would take your time to solve that problem. And we are not going to do it. You have a formula, you have information. Do it for yourself and it'll help you understand. The only difference is you're going from month to a year instead of a year to many years. Again, just messing around with the timeline. So take a break. We are going to start a new topic today, which, by the way, is going to take the same ideas, but is an important decision-making session. And in this week, you'll recognize how to evaluate good ideas and bad ideas and pick, hopefully, the good ones. See you soon.